All right, we're on to 5.6, and 5.6 is equations of quadratic functions from their graphs. Now, we want to be able to take some points, and then we want to be able to find the graph that goes with those points. So let's review real quick. What is the standard equation of a quadratic? Here you have it. Y equals ax squared plus bx plus c. That's the standard equation. Now, what we have here, basically, we have a bunch of things we don't know. We don't know x, we don't know y, we don't know a, we don't know b, we don't know c. Now, in example number 1, they give you 3 points. 3 points that have x and y in them. So what I'm going to do right now is I'm going to go ahead and just substitute those points in for x and y. So the first one would be negative 11 equals, and then negative 2 is my x value, so it's 4a minus 2b plus c. That's my first one. And then the next one will be the y value is 13. And then my x value is 4, so when I sub that in I get 16a plus 4b plus c. And then, again, I am going to do that with the next point, which is 629. So 29 equals 36a plus 6b plus c. Now, what you'll notice now is that we have 3 equations, and we have 3 things we don't know, which are a, b, and c. And remember, the rule is that you need the same number of equations as unknowns if you want to actually find an answer. You need the same number of unique equations. So here, we would just solve this just like we did in chapter 4 with solving systems of equations. So you want to just go ahead and combine them and get rid of stuff. So let's just take a look at the top 2 real fast. I'm going to multiply this one by 2. So I get negative 22 equals 8a minus 4b plus c. And this one will be still 13 equals 16a plus 4b plus c. I'm going to add these 2 together. And that will give me 9, negative 9 equals 24a plus 2c. Simple. Now, usually on these, the easiest thing to do actually is to get rid of the c first. So let's just back up and do that. Sometimes you'll go down a road and you realize, wait, if I get rid of c, life is just easier. So let me go back through and get rid of c on all of these. That's how they're solving it too, and that is the easier way to do it. So if I just subtract one from the other, if I subtract this one from this one, my c's, it will be c minus c, and that'll work. So I'm going to subtract 13 from 11, that's negative 24, equals negative 12a minus 6b, and my c's go away. Yay. Then I'll do the same thing here. I'm going to subtract this one from this one. So that would give me 16 equals 20a, and then here 2b plus 2b. Anyway, what you should be noticing at this point is that this is the same type of solving that we were doing in last chapter. So here I'm going to go ahead and factor out a 6 to make life easier here. So that gives me negative 4 equals negative 2a minus b. Actually, I'm going to factor out, let's do this again. I'm going to factor out a negative 6 to make my life a lot easier. That gives me 4 equals 2a plus b. And here I can factor out a 2. That gives me 8 equals 10a plus b. Subtract the bottom one from the top one, I get negative 4 equals negative 8a. A must equal 2. So if a equals 2, then I can sub that back in here. So I get 4 equals 4 plus b. Wait, that's wrong. Oh my gosh. Okay. See, this is the problem with these type of equations, is that when you're just rolling through it and if you're not paying very careful attention, what I did here was I said that 4 divided by 8 was 2. Haha, not. All right, what that should be is 0.5 or 1/2. And I always prefer fractions, so we're gonna do that. So then we have 4 equals 2 times 1/2, which is 1, plus b. That means b equals 3. And then I can go ahead and shove those into one of the other equations to get my c. So that's how you're working this. You get, with a parabola, you must have 3 points. You take those 3 points and you plug them into the standard equation, and then you solve that system of equations. So again, in example 2, they have find the particular equation of the quadratic function containing 0, 5. And you need to be paying attention all the time in math, because sometimes you get a chance to use a skill or something that you know and it makes your life lots easier, and that's going to happen this time. So find the particular equation of the quadratic function containing 0, 5. So right away we know we're going to start with ax squared plus bx plus c, right? Now the first point they give us is 0, 5. When they give us an x value of 0 and a corresponding y value, what they have really given us is the y-intercept. So life just got a whole lot easier, because now we know that c is 5. Because c represents the intercept. Let me just give you an example. I could go ahead and put this in, and what I would get was 5 equals 0a plus 0b plus, plus c. So here c equals 5. As soon as we see the y-intercept is 5, we know that c is 5, because c represents the y-intercept. So life just got easier. Now we only are going to have to deal with 2 equations. We have the point 213, and we also have the point 326. All right, so here I'm going to say 13 equals 4a plus 2b plus c. And here I'm going to say 26 equals, not c, 5. Because remember, 5 is our c. We already know that. We already know that c equals 5 because that's the y-intercept. And then here we get 26 equals 9x, or 9a plus 3b plus 5. Now, real quick, y equals ax squared plus bx plus c, and y equals mx plus b. These both share the same thing. This value on the end that has no x involved with it, that always represents the y-intercept. And I'm just going to go briefly over why is that the case? Because the y-intercept is wherever x is 0. And if I put a 0 into these 2 equations for my x, what I quickly learn is that this goes to 0, this goes to 0, that goes to 0. And all you're left with is that c and that b. That extra variable on the end that is not affected by x at all will always represent your y-intercept. So just know that whenever you get a 0 and a 5, it's really much faster to know that. All right, so what do I really have here? I guess we'll just solve by, we'll bring this over first. I'm going to bring the 5 over with the 13, so that gives me, and I'm going to multiply this by 3. So I want to multiply this whole thing by 3. I'm going to multiply this whole thing by 2. And why I'm doing that is because I want to get my b's to equal each other. Okay, but before I do that, I'm going to go ahead and move this 5 over to this side. That will leave me with an 8. And if I move this 5 over to the other side, that will leave me with a 21. So now I'm going to go ahead and multiply through. I get 24 equals 12a plus 6b. And down here I get 42 equals 18a plus 6b. So now I can subtract the bottom one from the top one. So 24 minus 42 is a negative 18. 12 minus 18 is negative 6, and that's 0. So here, divide both sides by negative 6. This time I'll do it properly. A is 3. I already know that C is 5. So in order to find B, I can just substitute this back in. So I get 24 equals 12 times 3 is 36, plus 6 times B. So that would be negative 12 equals 6B. So B must equal negative 2. And voila, we have figured that out. Now, so remember, a few things to always recall is that however many unknowns you have, that's how many equations you need. For example, when we had this with the 5 at the end, we have two unknowns. We have A and B are unknown. If only A and B are unknown, I only need 2 equations. If A, B, and C are unknown, I need 3 equations. If A, B, C, and D were unknown, I would need 4 equations. Just like when I have 3x plus 7 equals 14. Why can I solve this equation? I can solve it because I have one thing that I don't know, and I have one equation. Therefore, I can solve for x. So just things to think about as you work through these problems. Now, we want to find in example 3, we want to find the particular equation of the quadratic function. Before I keep reading, make space to write it down. All right, with the vertex is at 2, negative 5, and contains the point 3, 1. Now, when they give us the vertex, the easiest thing to do is not put it into the standard form of a parabola. In this case, with giving us the vertex, we want to put it in vertex form. That makes life easier. So vertex form, if you remember, is y minus k equals a x minus h squared, where my vertex is represented by hk. So I can just take these values and plop them in. So y minus a negative 5 equals a x minus 2 squared. Yay! The number one mistake kids will make when they're doing this is when they go to sub in this negative 5, they'll write it down as y minus 5. They'll forget either that the negative has to be there, they'll forget about this one, or they'll know about this one and forget about this one. You have to make sure they're both there. So really, this is equivalent to y plus 5, right? Okay, so y plus 5 equals a x minus 2 squared. So we have 3 things we don't know, but we have an x and y value over here. And if I were to put these in, that's going to leave me with one equation and one thing that I don't know. I can solve that. So let's go ahead and do that. I'm going to say 1 plus 5 equals a 3 minus 2 squared. Well, that couldn't get any easier because this is going to simplify down to 1. So I get that 6 equals a. How nice is that? But the idea here is we got to this point when I substituted in my x and my y value. I have one thing that I don't know and I have one equation. That's solvable. I can actually find the specific point that represents. The reason why if we have y equals mx plus b, and let's say you have y equals 3x plus 4, the reason this isn't a point and this is a line is because there's more than one point that satisfies this. This could be like, so in this situation, 1, 2, 3, 4, here you are as the intercept. So this line, any point along this line works to solve, it works in this equation. The only way to narrow this down to one point is to come up with another line. Let's say y equals negative 2x. Okay, well now, if I'm trying to solve this set of equations, what I have to remember is that this is a line because I have one equation and 2 unknowns. This is a line because I have one equation and 2 unknowns. And when I graph both of them, where they intersect is the set. That's how I'm able to find the one point. I have 2 equations, 2 things that I don't know. I can find the one point that works for both. So in this situation, it would of course be like here and I can come up with one point that's a solution. But if I have one equation and 2 unknowns, I can never get a single point as a solution. All right, so you have your exercises to do here in 5, 6, and just the key here is to be careful and to be very vigilant as you work your way through the problems. Good luck.